Hi, in this video we are going to learn some new interesting features in Java 8. We are going to talk about default methods for interfaces, Lambda expressions, and functional interfaces. So let's get started with default methods for interfaces. So this was added in Java 8. What it does is it lets you add non-abstract methods in interfaces. So for example, here this is a method, it's not an abstract method as you can see it's completely implemented over here. So now you can do that in an interface in Java 8, which we were not able to do earlier. However, you need to use this default keyword. So any implemented method in an interface should have this default keyword. So let's go to Eclipse so that we can run a quick test. So here is I have this calculator interface which has this abstract method, but I also have this sum method which is implemented, and that's why it has this default keyword. Let's see what will happen if I get rid of this default keyword. So now it's going to complain because it's going to say abstract methods do not specify a body, so you cannot have a body in an abstract method. So let me add back the default keyword. So now just to illustrate, I have this quick test. So here I have this anonymous inner class which is implementing the calculator interface. So it's basically implementing this the calculate method, and note here, so I'm calling the sum method from here, which has already been implemented in the interface with using this default keyword. So from this implementation of this abstract method calculate, I'm invoking the same sum method which is already there in the interface. And then on this calculator instance, I can call this calculate method which was implemented by this inner class, and I can also directly call the sum method which is a default method in the interface. So if I just quickly execute this, so first it calls the calculate method. The calculate in turn calls the sum internally, and we get back a result 11. And in the second case, we are directly calling the sum method, and we get back the same result. So this was a simple example to illustrate the default method in an interface. Now let's go back with the rest of so the next topic is Lambda expression, and this is a very cool, interesting feature which was added in Java 8. What it is it's basically an anonymous function with no declaration, and so it can capture the behavior but with much less code, which I will show with an example. And you can also look at it as a shorthand that allows to write and use the function in the same place. So basically you don't have to declare the function earlier. You just write and use the function in the same place. Something similar to the anonymous inner class, but of course that's a class, whereas here we are talking about a function. And it can replace verbose anonymous inner classes. As we all know, in Java we have this inner classes, anonymous inner classes, which are quite powerful, but they can be very verbose, and that can be eliminated a little bit with lambda expression. Lambda expression, it also brings functional programming to Java. Java, as we all know, it's highly object-oriented language, so the focus is primarily on objects. But here we, with lambdas, the focus is on functions. However, because it's object-oriented, so even lambdas they're objects of type functional interface, which also I'll explain later with an example. So coming back to the syntax for lambdas, it looks something like this. So the first part, these are the parameters of the function, and then we have to use this keyword for lambda, which is like a hyphen and a greater than sign, and the rest is the actual method body within the curly braces. And this code can actually become much shorter. We can get rid of the types in the parameters, because the compiler, depending on the situation, it can automatically figure that out. So it can be as small as this, s1 comma s2. So there are two parameters, and then if it's just a one-line method, we could get rid of the curly braces and the return, so it just becomes something like this. So it's simply comparing string 1 with string 2 and returning the value. So this is an example of lambda. Another very small example is this. What this means is, the function actually has, this anonymous function actually has no parameter, and this is the keyword for lambda, and this function is simply returning hello. That's all it's doing. Now let's go back to Eclipse so that we can go through some simple test for lambda. So here in test 1, I'm going to illustrate how lambdas can help in doing things in a much less with much less amount of code, and it looks much simpler. So here I have a list of string names. So names is a list of strings, and it has all these values in it, and my goal will be to just sort this list of strings. So before Java 8, we could achieve this by calling this sort method on collections. We'll pass pass names, which is a list of string, and then we can pass the comparator, which is here, it's an anonymous inner class, which is implementing the compare method. So what it does, it takes two strings, it compares them and simply returns the result. But just for comparing the two strings, we have to use this anonymous inner class, which does the work, but it's an awful lot of codes. It's very, very verbose. Next, let me show you how we can achieve the same functionality using lambdas. So again, I'm calling the same sort method, and instead of the anonymous inner class, I have this lambda, and what it is doing is it's taking two parameters, the two strings that I need to pass, string s1 and string s2. So these are the two parameters, and then this is the body of the function, where we compare the two strings and we return the result, so that the sort method can sort it based on the result comparing the two strings. Actually, I can make the code even smaller to something like this, because the compiler already knows, the parameter type. So I could simply do s1 comma s2, and because it's just a one-line function, so I can get rid of the curly braces and the return, and I can simply have this, and it's telling, what it's doing is the same thing, comparing the two string s1 and s2, and it will return so then we are printing the sorted name. So if I quickly run this test, you can see what it does. I'll comment out my test2. I'll save it, and let me run this. Oops, I made a mistake. Try again. Okay. So as you can see, it sorted these strings which were there in the names. So now you can see that it's sorted B, C, T, X, and Z. So the first one was done by using the anonymous inner class. The second one was done using the Lambda expression, which is much less amount of code, but it got the same result, and so it's much easier to use compared to this anonymous inner class. And this is a simple example. If in a real life code, it can be a much bigger saving. Just to illustrate it a little bit more, I have a second method. So here again, so we have a new thread, and we are trying to pass an implementation of the runnable interface. So this anonymous inner class is implementing this runnable interface, and that's passed to the thread. And in the run method, we are simply saying hello, and it's coming from using the anonymous inner class. Now the same thing can be done using lambdas. So instead of using the anonymous inner class to implement this runnable interface, which has this run method, we can simply have a lambda which is actually doing the same thing as the anonymous inner class. It's implementing the runnable interface. So the runnable interface has a run method with no parameters. Note the same thing, the lambda has the same thing, no parameters for the method, and it's kind of doing the same thing, printing this line hello, but it says here it's saying that it's using the lambda expression and not the anonymous inner class. So again, as you see, this amount of code can be replaced with a simple lambda expression like this. So let me run my test2. Shift X. Yeah, see, so now this came from that inner class, and this was printed from the lambda. So as you can see, lambda, it's an anonymous function. It's, even though it's an object though of type functional interface. So what it primarily does is it implements the abstract method in the functional interface. So in this case, for the runnable interface, it implemented the run method, and here it was implementing the compare in the previous example that I